you're doing well. Welcome to another session of MATLAB for Mechanical Engineers course. This session is about programming essentials. In this session, we'll be learning concepts that will help you in building coding logic as well as in debugging a code. Now, let us do a small recap of what we learned in the last session. We first had an introduction into MATLAB's user interface. We learned what a command window is, what an editor window is, and what workspace is. And then we learned the concept of arrays. We created one-dimensional and two-dimensional arrays in MATLAB. We also learned how we can access elements from inside those arrays. And then we moved to learning the concept of looping, right? We understood what looping means. We implemented for loop to study how it functions. After that, we created one-dimensional and two-dimensional plots by using the plot and contour functions. And finally, we moved on to the concept of functions. We understood how one can define and call a function in MATLAB. This week, we'll learn how the control flows inside a code, or in other words, how a computer would execute a code, especially when using if-else and for loop structures. We will discuss about pseudocodes and flowcharts, which are tools that will help us in developing program logic. And finally, we'll learn how we can use MATLAB's debugging tools to spot and remove errors from inside a code. And by the end of this session, our learners will understand how a computer would execute a code. This understanding is necessary, especially if one wants to write a correct code and implement correct logic. The learners will also be able to build coding logic by using tools like pseudocodes and flowcharts. When writing simple codes, pseudocodes and flowcharts are not that necessary. We can very well write a code without using pseudocodes and flowcharts. But when dealing with complex codes or complex logics, pseudocodes and flowcharts become very helpful. They help us in developing a clear idea of the program logic and also implement the same. And finally, the learners will also be able to debug any code by using MATLAB's inbuilt tools. Let us start with the first topic of discussion, which is control flow inside a code. The control flow inside a code is sequential by default, which means that a code is executed line by line. If I have a code of 10 lines, line 1 is going to get executed first, followed by line 2, followed by line 3, and so on. And if I have multiple statements inside a single line, the first statement from the left is going to get executed first, followed by the second from the left, and third from the left, and so on, right? So by default, the control is going to flow from top to bottom and left to right. But whenever there is an assignment operator in use, the right-hand side gets evaluated first, and then the result of the right-hand side is then stored into the left-hand side, which is a variable, right? Let us understand this with the help of a few examples. So we have 3 lines of code here. In the first line, we have a is equal to 3 plus 2. The MATLAB is going to execute the right-hand side, right, which is 3 plus 2. And it's going to assign the result, which is 5, to the variable, right, which is a in this case. And in the second line, we have 2 statements, b is equal to 10 and c is equal to a plus b. Each statement is terminated by a semicolon operator. So a semicolon operator separates 2 statements, right? So in the first statement, the value of 10 is assigned to b, and in the second statement, so MATLAB will first compute a plus b. Value of a is 5 from the previous line. Value of b is 10. A plus b is 15. And this result is going to get stored inside C. And in the third line, we again have 2 statements. A is equal to 1 and a is equal to a plus 1. Now, when we execute this statement, the previous value of a, which is 5, is going to get overwritten by 1, right? And when we execute this statement, a is equal to a plus 1, Again, the MATLAB is going to execute the right hand side first. The current value of a is 1. 1 plus 1 is 2. And this result, which is 2, is going to get assigned to the variable a, right? And at the end of this line, the value of a will be 2. It will not be 1, right? Now, sometimes we might not want to have a sequential flow of control, right? We might want to skip a few statements based on a certain condition, or repeatedly execute a set of statements for a certain number of times, right? So in other words, we might want to manipulate the flow of control. So that is when we use something called as a control structure. A control structure can be categorized into two types, the selection type and the repetition type. So selection type basically means that you are selecting the set of statements that you want to run, right? So it's used for decision making or branching, right? Examples for selection type control structures are if else, switch case, etc. So repetition means that you want to run a set of lines or a set of statements for a certain number of times, right? This is also called as looping. And examples for the repetition type control structures are for, while, do while, etc. For this session, our focus is going to be on if else, and for control structures. An if structure decides if a set of statements should be executed or not. The syntax for the if structure is shown here. It starts with the if keyword followed by the condition, and the end keyword marks the end of the if structure, and the statements to be conditionally executed are written inside the if and end keywords, right? So the execution of these statements depends on this condition, right? If this condition is satisfied, if this condition is true, only then the statement 1 and 2 will be executed. If this condition is not satisfied, right? In other words, if this condition is evaluated to false, then these statements will not be executed. And a condition can be a simple expression like a less than 6, right? If I have a condition like a less than 6, if the value of a is less than 6, then MATLAB is going to run these statements, right? The control is going to step inside the if branch and run these two statements. But if the condition is false, right, if the value of a is actually, it's not less than 6, then these conditions will not be executed, right? Here, so when executing an if structure, MATLAB is going to first evaluate the condition. If the condition is true, MATLAB is going to run the statements inside the if block and then terminate the if structure. But if the condition is false, MATLAB is going to terminate the if structure without running the statements inside the if block, right? The if else structure is basically an extension of the if structure. And the syntax of the if else structure is shown here. We can notice that in addition to the if block, as seen in the if structure, we also have an else block in the if else structure, right? So the if else structure is going to execute the statements inside the if block if the condition is true, and if the condition is false, it is going to execute the statements inside the else block, right? And then it's going to terminate the if else structure. Now this flow of control can be explained better with the help of the diagram shown here. Now when MATLAB encounters an if else structure, again it's going to first check the condition. If the condition is true, the control is going to flow inside the if block. Statements 1 and 2 are going to get executed, right? And then the if else structure is going to terminate. If the condition is false, then the control is going to step inside the else block. It is not going to go inside the if block, it's going to go inside the else block, right? Statements 3 and 4 will be executed, and then the if else structure is going to terminate, right? It is important to note that at a time one of these blocks is going to get executed. Either if block is getting executed or the else block is getting executed. So this is the working of the if else structure. Now let us understand how the control flows inside a for loop. A for loop is used to run a piece of code or a set of statements for a certain number of times. The syntax of the for loop is as shown here. It starts with the for keyword followed by an expression, and the statements which are to be repeatedly executed should be written inside the for and end keyword. And end keyword marks the termination of the for loop. Now coming back to the expression contains an array assigned to a variable. Now this array is a one-dimensional array. It is of the form as shown here. It has a start value, it has a last value, and multiple values in between. And the length of this array determines how many times these statements are going to get executed. In other words, the number of iterations a for loop is going to run for is going to be determined by the length of the array assigned to this loop variable. If the length of this array is 10, then these statements are going to get executed for 10 times. If the length of this array is 20, then these statements are going to get executed 20 times, and so on. And when I say length, I'm referring to the number of elements inside the array. An array of 10 elements is going to have a length of 10. And it is important to note that this array could be of any type. So any type in the sense it could be a numerical array, it could be a character array, string array, or so on. And it can also be of any length, right? So whatever is the length of the array, the for loop is going to run for so many iterations. The length of the array can also be 1, right? If there is only one element inside the array, that will also work. The for loop will only run these statements, right? Statement 1 and 2 for just one time. This variable is called a loop variable. In this array, we know that the for loop runs one iteration for every element inside the array. And this loop variable is going to keep track of the corresponding element for every iteration. What that means is, in the first iteration, this loop variable is going to take the first value inside the array, which is the stat val. In the second iteration, the loop variable is going to assume the second value inside the array, right? And so on. And in the final iteration, this loop variable will assume the last value of the array. This slide gives us a visual representation of the flow of control inside the for loop. Whenever the for loop is executed in MATLAB, the loop variable is first initialized with the first value inside the array, and then the statements written inside the for loop are executed for the first time. After that, the loop variable takes the next element, in this case the second element of this array, and then the statements are run for the second time, and this keeps repeating until the loop variable assumes the last element of the array, and then the statements are run for the last time, and finally when this condition is evaluated, this condition will be true, and that is when the for loop terminates. Now let us understand how the flow of control is affected when using functions inside the main code. A function is not a control structure, but since a function is generally defined in a separate file, whenever we're using that function inside the main code, the control has to jump from the main code into that function file, execute the code inside that file, and return back to the main code again. Let us understand this with the help of the following example. In the right hand side, we've defined a function called add, which is going to receive two inputs, add them up, and return the output to the main code. This function definition is contained inside the function file add.m. Now on the left, we have the main code where we've initialized a and b, and here in this line, we've called the add function. So this is a function called statement. And when MATLAB executes this statement, it is first going to search for the function file named add.m. And once it locates the function file, the values of a and b are going to be passed inside input 1 and input 2, right? And the entire function code is going to get executed. And the value of output is then passed back to the main code. So we can see how the control jumps from the main code to the function file, executes the function code and returns back to the main code. After that, we're basically printing the variable C in the command window. And it is important to note that in MATLAB, by default, the variables have a local scope, which means the variables defined in the main code, A, B, and C, they cannot be accessed from inside the function. And similarly, the variables used in the function code, input 1, input 2, and output, cannot be accessed in the main code. Now that is why we have to send arguments to the function. Now let us understand this concept further by coding a few examples in MATLAB. Okay, we're in the MATLAB's editor window now. Let us write some codes to implement the control structures we've learned so far, and also to understand the flow of control through these structures more thoroughly. Let us start with the if and if-else structures. Let us write a code to check the pass or fail status for a given mark. So this line right here is called a comment, and it is not going to be executed. In fact, any line that is preceded by the percentage symbol is not going to be executed in MATLAB. So we start the code with clear, close, and CLC by default. Now we have to create a variable called mark in order to store the mark, and we initialize this variable with a random mark, say 60. Now we need to create a condition. Let us assume that more than or equal to 50 is pass and less than 50 is fail. To implement this condition, we can use the if-else structure. It starts with if followed by the condition, and the condition is mark greater than or equal to 50. Now if this condition is satisfied, if mark is greater than or equal to 50, then we have to let the user know that they've passed. The disp command is used to print on the command window. So we print congratulations, you have passed, right? Now, if this condition is not satisfied, if the mark obtained is less than 50, then we have to let the user know that they have failed. To do this, we make use of the else statement. We just type else display sorry you have failed, and we terminate the if-else structure by using the end keyword. Now let us run this code. MATLAB is prompting us to save the code first. So we're going to save the code as pass fail status, right? We hit the save button, and you can see that the code has run. For a mark of 60, the code shows congratulations, you have passed, right? The code is working fine. Now let us change the mark to 40 and see what happens to the result. So the output says sorry you have failed, right? So the code is working fine. Now let us extend this code further. For the people who have passed and scored above 80, for example, we can also let them know that they've passed with distinction, right? To do this, we can add one more if structure inside the if block. We can say if mark is greater than or equal to 80, display with distinction. We can then end the if structure, right? Now this is called as a nested if implementation. We've basically implemented one if structure inside another if structure, right? So what we've done here is we've initialized a variable called mark with some random mark, and if that mark is greater than or equal to 50, we first print congratulations, you have passed. And then again, inside the same if block, we again check if the mark is greater than or equal to 80. If it is greater than or equal to 80, then we also print with distinction, right? And if the mark is less than 50, then that is when the else block is going to get executed, where we print, sorry, you have failed, right? Now let us run the code again. Yeah, so there should be no change in the result because we haven't changed marks. Now let us change this mark to 90. And when we run the code, we can see the output here. It says, congratulations, you have passed with distinction, right? And if we have a mark of 60, it's just going to say, congratulations, you have passed. I hope the working and the flow of control through the if and the if else structures were clear. Now let us move on to the for structure. To understand the flow of control through the for structure, we're going to first write a code to compute the factorial of a number, right? A factorial can be defined as the product of all the positive integers that are less than and equal to that number. For example, the factorial of 6 is nothing but 1 times, 2 times, 3 times, 4 times, 5 times 6, right? Which is equal to 720. You can see that when computing a factorial for a number, the multiplication operation is repetitive, right? And this calls for looping, and that is why we're going to implement a for loop to calculate the factorial of a number. So the logic is going to be simple. We'll first create a variable called fact and initialize it with 1. And we'll create an array that spans from 1 to 6 by using the colon operator. Now using for loop, we will take the elements from inside this array one by one in each iteration and multiply that element with the fact variable, right? And also overwrite the value of the fact variable with the new value, right? Now let us do this. We start with the for keyword followed by the loop variable, and we're going to assign this array to the loop variable, right? Now this loop variable is going to assume the values inside the array one by one for each iteration of the for loop. And inside the for loop, we multiply fact with I and reassign this value to the fact variable itself. So this is how we're going to overwrite the value of the fact variable with the new value, right? Now we can end the for loop by using the end keyword. Now before executing this code, let us write the customary clear, close and CLC statements. We also want to keep track of the values of I and the fact variables in each iteration. Let us use the disp command to display the values of I. So the first, this statement is going to display the characters as they are, I is equal to, and this statement is going to display the value of I. And to display the value of fact, we just need to remove the semicolon, right? Now let us run this code. I'm going to save this as factorial.m. We can see that the code has run, and if we can just enlarge the command window, we can see that the values of I and the fact variables have been printed for every iteration. In the first iteration, the value of I was 1 and fact was also 1. In the second iteration, value of I was 2, fact was also 2. Third iteration, value of I was 3 and fact is 6, 2 into 3. And in the fourth iteration, value of I is 4 and fact is 6 into 4, right? And so on. In the final iteration, the value of fact is 720, which is the intended result. Now, this working can be understood even better by running the code line by line and one iteration at a time. To do this, we'll be using the step button that can be seen here. I'm using MATLAB version R2022A. If you're using an older version of MATLAB, you might not find the step option here. You will have to first place a breakpoint and then run the code in order to activate the step button, right? And you would find the step button in this region after it gets activated. And in the older version, you will have to click on a small dashed line that would appear in this region corresponding to each line number to place a breakpoint. A small red circle would denote that the breakpoint is active, right? But in this version, that is not necessary. The step option or the step button is readily available in this region. I'm going to use this button and run the code line by line from the first line or the fourth line. Clicking on this once is going to bring the control to the first line. From here, we can run the code line by line and actually see the result. Let us run line number 4. So that cleared our workspace. We ran line number 5 and running line number 6 will clear the command window. Running line number 8 will create a variable called fact and initialize it with a value of 1. Line number 9 will create an array and initialize it with the value that you can see here. Now let us understand what is happening inside the for loop. As soon as line number 11 gets executed, you can see here that the loop variable I is being initialized with the first value of the array, which is 1. Line number 12 is going to display the characters I is equal to. Line number 13 is printing the value of I, and line number 14 is calculating fact and printing the value of the fact variable. And clicking on step again, you can see that the control jumps back to line number 12, right? And now, if we look at the workspace, we can see that I has taken the second value of the array. Now we again print the value of I, and then we print fact, and clicking on step again is going to take the control back to line number 12, right? And now you can see that I has taken a value of 3, which is the third value of this element, right? Now we can keep on clicking on step until the end of the code to understand how MATLAB is interpreting each line of your code, right? This feature is actually very helpful while debugging. So we'll be talking about breakpoints and the step button in more detail when we discuss about debugging. Now, using step button can also help us understand how the control flows when a function is called from the main code, right? So I've written a small code here to demonstrate that. I've created a function called addition, which is going to receive 2 inputs and return an output, which is the sum. And this function is being called from the main code, right, in this line. Now let us run the code line by line and trace out the flow of control, right? Let us activate this first by clicking on it once. So we run line number 3, which is going to clear, line number 4, line number 5, line number 7 and 8 are going to create the variables A and B respectively and initialize those variables. Now let us step into the function by using the step in button. Before stepping in, I would like you to pay attention to what is happening in the workspace. So currently the workspace contains variables A and B and their corresponding values. But when we step into this function, you can see that the control has moved into the function or the control has stepped inside the function, and in the workspace, A and B are no longer available